Hi, this is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss some more problems related to the equilibrium and free body diagrams. So let's see question number 1. A sphere rests in a smooth V-shaped groove and subjected to a spring force. A spring is compressed to a length of 100 mm from its free length of 150 mm. Its stiffness of spring is 2 Newton per mm. Find the support reactions at A and B. So this is a question. A sphere rests between two inclined planes having angles 30 degree and 60 degree. The weight of the sphere is 40 Newton and it is attached with a spring. So while drawing the free body diagram of this spring, first of all, a spring force will be exerted by the spring on the sphere in downward direction. Now, you know spring force F equal to K delta X. Here K is given as 2 Newton per mm stiffness of spring and delta X will be equal to 150 mm minus 100 mm because the free length is 150 mm and the length of spring when compressed is 100 mm. That is displacement or X is 150 minus 100, that is 50 mm. So the force of spring F equal to K delta X, that is 2 multiplied by 50, so it will be 100 Newton. Now we come to know that 100 Newton spring force will act in downward direction. Now this sphere is also in contact with two inclined surfaces, so inclined surfaces will exert the reactions RA and RB in perpendicular direction. You can see in the diagram the reaction RA will make 30 degree angle with vertical and reaction RB will make 60 degree angle with the vertical. So this is how we will draw the free body diagram. Then we will have to resolve the inclined forces. You can see in the diagram RA and RB are the only inclined forces. So we can resolve these forces. RA will be resolved as RA cos 30 in vertical upward direction and RA sin 30 in horizontal positive x direction. Similarly, RB can be resolved as RB cos 60 in vertical upward direction and RB sin 60 in negative x direction. Now we will apply the conditions of equilibrium for concurrent forces, that is sigma fx equal to 0 and sigma fy equal to 0. So the first equation will be RA sin 30 minus RB sin 60 equal to 0, or we can say RA equal to under root 3 RB. Now similarly we will make the equation for vertical forces sigma Fy equal to 0. So RA cos 30 and RB cos 60 are in upward direction. So equation will be RA cos 30 plus RB cos 60 minus 40 minus 100 equal to 0. In this way we can get the value of RB as 70 Newton and RA will be 70 root 3 Newton. So this is how we will solve this problem. Now let's see the second question. A pulley of 1 meter radius supporting a load of 500 Newton is mounted at point B on a horizontal beam. Now if beam weighs 200 Newton and pulley weighs 50 Newton, find the hinge reactions at C. Now it is clear from the diagram that we have two objects. One is beam and another one is pulley. If we draw the free body diagram of beam, we will have one vertical reaction at A point, one vertical, one horizontal reaction at C point, and one vertical, one horizontal reaction at B point. So we will have 5 unknowns in total in case of beam. But if we draw free body diagram of the pulley, we will have only one vertical reaction and one horizontal reaction at the hinge point B. Okay, so we will draw the free body diagram of the pulley first. Now let's see the free body diagram of the pulley. At point B we will have RBH and RBV since it is hinge. Similarly 30 Newton 50 Newton weight will act at the center in downward direction. 500 Newton force is acting in downward direction, and since the pulley is frictionless, so tension in both sides will be same. So in upward direction also we will have the 500 Newton force, but it will be inclined. So if we assume the horizontal angle theta, then we can calculate the value of theta. Cos theta equal to 4 by 5 and sin theta equal to 3 by 5. Now once we have resolved this 500 Newton force, we can apply conditions of equilibrium sigma fx 0. So plus RBH minus 500 cos theta equal to 0. So RBH equal to 400 Newton. Similarly sigma Fy equal to 0. So plus RBV minus 50 minus 500 plus 500 sin theta equal to 0. So RBV equal to 250 Newton. Now once we have calculated the values of RBH and RBV, we will draw the free body diagram of the beam. While drawing the free body diagram of the beam, these reactions will act in opposite direction. That is, RBH will be taken in negative x direction and RBV will be taken in downward vertical direction. Now the weight of the beam will act at half of the distance, so it will act at 2.5 meter from end A. Now we can draw the free body diagram of beam. At point C it is hinged, so we will have one vertical and one horizontal reaction, RCH and RCV. At point A we have simple support, so it will be one vertical reaction RA. Make equations for horizontal force sigma fx equal to 0. You will get minus RCH minus 400 equal to 0. So RCH equal to minus 400 Newton. That is 400 Newton in positive x direction. Then we will make equation for sum of all vertical forces. So RA plus RCV minus 200 minus 250 equal to 0. So RA plus RCV equal to 450 Newton. Now make equation for sigma MA equal to 0. Sum of all movements about point A equal to 0. So movement of RA and movement of RCH, movement of 400 Newton horizontal force will be 0, since their lines of action are passing through that point only. Now RCV will try to rotate the body in anti-clockwise direction, and 250 and 200 Newton forces will try to rotate the body in clockwise direction. So RCV's movement will be positive and 200 and 250 Newton's movement will be negative. So RCV into 5 minus 200 into 2.5 minus 250 into 3 equal to 0. It will give you the value of RCV as 250 Newton. So this is how we will calculate the value of hinge reactions RCH and RCV. Now let's take the third question. On one end of rod AB rests in corner A and other is supplied by force F. Length and weight of bar is 4 meter and 100 Newton. Find the force F and reaction at A for equilibrium. So the first thing in this question is that at point A the rod will have the hinge support. Point A will react as the hinge support. So at point A we will have the hinge reactions, that is one vertical reaction and one horizontal reaction. Weight of the rod will act at half of the 4 meter length, that is at 2 meter. It will act vertically downward direction, 100 Newton force. Now we will draw a horizontal line at B. So alternate angle will be 45 degree. So total angle is 45 and angle of F is 25. So angle of F with horizontal will be 20 degree. Now we can resolve this F in horizontal and vertical direction as F cos 20 and F sin 20. Now make equations sigma fx 0, sigma fy 0 and sigma m equal to 0. So first equation will be plus RAH minus F cos 20 equal to 0, RAH equal to F cos 20. Sum of all vertical forces equal to 0. It will give you plus RAV minus 100 minus F sin 20 equal to 0. Equation number 2. Then we will take moment about A point. So moment of RAH and RAV will be 0. Now F sin 20 will try to rotate the body in clockwise direction and F cos 20 will try to rotate the body in anti-clockwise direction. So moment of F sin 20 will be minus F sin 20 multiplied by 4 cos 45. Similarly, 100 Newton will try to rotate the body in clockwise direction. So minus 100 into 2 cos 45. Then plus F cos 20 into 4 sin 45 equal to 0. So it will give you the value of F as 83.66 Newton. Now once you have calculated the value of F, you can calculate the value of RAH and RAV by putting the value of F in equation number 1 and equation number 2. So in this way you will get RAH has 78.6 Newton and RAV has 128.6 Newton. Now let's see the last question. 300 Newton sphere is supported by pull P and a 200 Newton weight 300 Newton weight passing over frictionless pulley. If alpha equal to 30 degree, calculate P and theta. You can see in the diagram that string is frictionless, so tension in both sides will be equal. So string in the tension will be 200 Newton. Now we can resolve these two inclined forces of P and 200 Newton. It will be P cos alpha in vertical upward direction and P sin alpha in positive x direction. Similarly, 200 cos 13 vertical upward direction and 200 sin 13 negative x direction. Now we can make equation sigma fx 0 and sigma fy equal to 0. So it will give you P sin alpha equal to 200 sin 30 or P sin alpha equal to 100 degree. This is equation number 1. Then sum of all vertical forces equal to 0. It will give you P cos alpha equal to 300 minus 200 cos 30 or P cos alpha equal to 126.8 Newton. Now by dividing equation number 1 and 2, we will get P sin alpha upon P cos alpha equal to 100 upon 126.8. So tan alpha equal to 100 upon 126.8. So alpha equal to tan inverse 100 upon 126.8, that is 38.26 degree. Once we have calculated the value of alpha, we can put this alpha in equation number 1. So we will get P sin 38.26 equal to 100. So P equal to 161.4 Newton. In this way, we will get the values of P and alpha. Thank you everyone.